Acids are a special class of chemical compounds, and the definition of what exactly an acid is has evolved over time. In this class, we will use a definition proposed by the Danish chemist Johannes Brønsted. An acid is a compound that can dissociate in solution into an H+ cation and some anion. The defining quality of acids by this definition is that they can dissociate in solution like ionic compounds, but in this case the cation is always H+, a hydrogen atom from which its only electron has been removed. The nucleus for by far the most common isotope of hydrogen is just a single proton. So it is often said that when acids dissociate, they release protons. The definition says nothing about the kind of anions that an acid must have. In fact, different acids differ in the type of anions that they have, whereas the cation is always H+. Let us look at a few common acids and at the naming conventions for them. For some acids, the anion is one single element, most commonly but not always a halogen. Such acids are called binary. Examples of such acids are HF, hydrofluoric acid, HCl, hydrochloric acid, HBr, hydrobromic acid, HI, hydroiodic acid, H2S, hydrosulfuric acid. The naming convention for binary acid is as follows. The name starts with the prefix hydro, followed by the name of the element that forms the anion, modified so it ends in ic, followed by the word acid. Thus, if an acid consists of a hydrogen atom and a chlorine atom, chemical formula HCl, and therefore dissociates in solution into the H+ cation and the Cl- anion, then the name of the acid is hydrochloric acid. The number of hydrogens in a binary acid is determined from the condition of overall electrical neutrality, just like for ionic compounds. When hydrogen atoms form cations, they always give up their only electron to form the H+ cation with charge plus. If the anion is formed by a halogen, then the charge of the anion is always minus. So in order for the acid to be overall electrically neutral, there must be one hydrogen atom per halogen atom, as in hydrochloric, hydrofluoric, hydrobromic, and hydroiodic acids. If the anion is formed, say, by sulfur, a nonmetal in group 16 that always forms anions with charge 2-, then in order for the acid to be overall electrically neutral, there must be 2 hydrogen atoms per each sulfur atom. Other acids have polyatomic anions that contain oxygen. Such acids are called oxyacids. Examples of such acids are H2SO4, sulfuric acid, H2SO3, sulfurous acid, H3PO4, phosphoric acid, H3PO3, phosphorus acid, HNO3, nitric acid, HNO2, nitrous acid, H2CO3, carbonic acid, HC2H3O2, acetic acid. The naming convention for oxyacids is as follows. Unlike for binary acids, the name does not start with the prefix hydro. Instead, it is based on the name of the polyatomic anion. If the name of the anion ends in ate, then the name of the acid is the name of the anion modified so that it ends in ic, followed by the word acid. For example, an acid that consists of H plus cations and the sulfate anion SO4 is called sulfuric acid. An acid that consists of an H plus cation and the nitrate anion NO3- is called nitric acid. An acid that consists of H plus cations and the phosphate anion PO4 is called phosphoric acid, and so on. If the name of the anion ends in ite, then the name of the acid is the name of the anion modified so that it ends in ose, followed by the word acid. For example, an acid that consists of H plus cations and the sulfite anion SO3 is called sulfurous acid. An acid that consists of an H plus cation and the nitrite anion NO2- is called nitrous acid. An acid that consists of H plus cations and the phosphite anion PO3 is called phosphorus acid, and so on. Acids are an important class of compounds with multiple applications in chemistry. We will talk more about acids when we discuss chemical reactions later in the course.